Welcome to another video for Stat 212. In this video, we're going to continue on with normal distributions, and now we're going to talk a little bit more about calculations of probability for different areas of the normal curve. So we talked a little bit about standardization. So as a reminder, if a variable is normally distributed, then we can convert those data values to z-values or z-scores, whatever you want to call them, and that can help us more quickly identify kind of the position of these values relative to other values in the distribution, right? So knowing that I have a data value of 73 may not be as helpful as knowing that the z-value for that data value is negative 1.2, right? So if I know the z-value, I automatically know the position of that data value relative to the other values in that variable. Whereas the data value itself is only meaningful contextually, which is still important. But in terms of finding areas of the normal curve, I'd rather have the z-values because then I can know immediately its position relative to the other data values in that variable. All right, so we're going to talk about standardization throughout the course because depending on the distribution we're looking at, so a lot of times when we do inference, there's going to be a lot of distributions that we look at, a lot of standardization that we use, like an F distribution, a chi-square distribution, a T distribution. So we'll talk about that more, but for now, let's talk about the normal distribution. So since this is a kind of a common and well-studied distribution shape, it's been well documented what percentages of the normal curve fall in different ranges. And so we're going to kind of start off with something called the empirical rule, which are just some very easy probabilities to remember, that if data is normally distributed, then 68% of all observations are going to fall within about 1 standard deviation of the mean. About 95% of all observations should fall within about 2 standard deviations of the mean, and approximately 99.7% should fall within about 3 standard deviations of the mean. Now, we can obviously calculate the percentage for any fine-grained area that I want, but those are 3 that are relatively easy to remember and I think are some nice guideposts when thinking about area under the normal curve. And so this visualization can also kind of help you out. Oops, I'm just drawing randomly now. So you can kind of see the 68% zone, the 95% zone, the 99.7% zone. And again, like the farther you go out, the less data you're going to see, which is why those data points, or I should say these percentages, are just going to approach 100% without actually quite getting there as we expand those bounds out. We're going to be using R in this class for doing some very limited calculations of areas under the normal curve. We'll only be doing it in this section, we'll only be doing it in this chapter, but we won't, we'll probably be using hypothesis test functions later on anyway, but it's good to have just a little bit of exposure to a function like p-norm, which can help us find the area under the normal curve for a very specific range of values. So for the exam, I'll just mention that you're not going to need to necessarily write some code for this. However, you should be generally familiar with the setup. So like given a code, you should know what it's doing, is what I would say. So like if you had some code, you should know that the first value is going to be the data value followed by the mean and standard deviation. And you should know, given some multiple choice options, which of these 4 codes seems to be accomplishing what is being asked in the question. But you won't necessarily just be writing code freehand on the exam or something like that. All right, so let's go ahead and practice here. The heights of adult men is a normally distributed random variable with mean 69.1 inches and standard deviation 2.9 inches. And let's define this random variable as h. What is the probability that h is less than 67? So the first thing that I'm going to do here is I'm going to kind of plot my information on this normal distribution just to get a picture of what's going on here. So I know that the mean of this distribution is about 69.1. I also know that the standard deviation is about 2.9. So if I extend up about 2.9 inches, I'm going to hit 72. Another 2.9 inches, and I'm going to hit 74.9. And I can also go down by the same interval, so I'm going to have 66.2, and then I'm going to see 63.3. And again, I'm not a perfect drawer here, so I know my intervals are not exactly right, but they're close enough, I think. The values are right. The positions are a little bit iffy, though. And so I'm looking for the probability that a randomly chosen male from this population is going to have a height less than 67 inches. So that's going to be somewhere, I'll use red again, somewhere in this range here is probably about where 67 is. I'll say 67. So I'm looking for this area under the normal curve. Now, I don't know what that is by memory. That would be odd if I just knew every range of any given values without calculating, and I guess maybe some people could have some tips for that. So I'm going to use an R function here. I'm going to use p norm, and I'm going to plug in x equals 67. Mu, so I would, this function would actually, you'd write it in mean equals 69.1. I think it's SD equals 2.9. And my lower tail here is going to be true because I am looking for the area of the curve on the lower tail side. So I'm going to say lower dot tail equals true in parentheses. And I happen to have R up here, so I'm going to pull R up. And I'm going to try typing in, I'll move that out of the way, p norm x equals 67. Mean equals 69.1, and you can actually see the options are showing up there. And actually, sorry, it's SD, not sigma. Or no, I did SD, so I did that correctly. SD equals 2.9, lower dot tail equals true. So now I'm going to run that. I think I can do Control Enter. Oops. Let's see. It doesn't like the x equals 67. Oh, is that because it not x? It might be some other value. So I'm just going to do 67. I know it's the first default argument, but maybe it's not x set at once there. So let's go ahead and try that. Control Enter. There we go. And so I get 23.45%. So that means that if let's say I need to pull this up again. I need to get R down here. So it's going to be, oh, I've already forgotten what that value is, 23.45%. So this is going to be about 23.45%. Will answer this question. That 23.45% of men should be below 67 inches from this given population. I could do the same thing with all these other ones. I won't necessarily do them all here. But I'll just kind of mention if you're doing greater than 73.6, or if you're doing greater than whatever, if you're doing greater than x, then you do the same p norm, 73.6. The mean is still 69.1. SD is still 2.9. But now I'm going to do lower dot tail equals false, because now I'm looking for the other side. I'm looking for the upper tail. So that's going to be, if this is 73.6, this would be the area of the curve I'm looking for. For the 63.8, notice that I am again looking for above 63.8. So it's going to be somewhere down here. But I'm looking for this area of the normal curve. So again, I'm going to stick with lower dot tail equals false again because I do want the upper tail probability for this one as well. Now a couple of these are a little bit trickier. So this one asks for the range between 66 and 72. And I think that's a really good challenge to think about, is how would you use the p-norm function to find this area of the curve? And I'll give you kind of a hint here, is that you're going to have to use it twice. You could use it in one line if you want to, or you could do it across a couple of lines if that's easier for you to kind of process. But you're going to need to get two tail probabilities, and then based on that information and using the fact that the entire area under the curve should be 1, what must be the area in the middle? And then lastly, here's a question. What is the probability that a man chosen at random will have a height at least 6 inches away from the mean? So I'm going to have to do a little bit of math here first. So I have 69.1. So I'm ultimately looking for 63.1. And I'm looking for 75.1. So then I need to do P norm of 63.1. Mean is going to be 69.1. SD equals 2.9. And this one I'm going to do lower dot tail equals true. And I'm going to add that to P norm 75.1, same stuff. But then the lower tail is going to be false for the second piece. So I want the upper tail for that second piece. And so if I add those two values together, I should get that tail probability. So I will go ahead and do this one in R just for another demonstration here. So I'm going to do, let's see, P, am I clicked on it? Okay, P norm 63.1. Lower dot tail equals true. I'm going to add that to, and I'll go ahead and do another line just so it's easier to see everything. I could do it on the same line, but either way it should work. And if I run this, I get 3.85%. With that, that means that this area plus this area is adding up to, so if I do kind of this arrow, this is going to be about 3.85% of men are going to be more than 6 inches away from the mean of 69.1 in this population.